Hello, thanks for tuning in. In this video, we're going to be creating an EKS cluster with FluxCD and Helm. This repo is public. You'll be able to access all of the files in there. It has everything you need to create it. And it has a README that will give you a brief summary on what you're going to be creating, which is an EKS cluster, some IAM roles to access it, and these are the Helm releases that will be deployed. So after you read the summary, then you can move on to the instructions. First thing is you have to have a hosted zone for a domain name that has the name servers in the registrar. Okay, so you have to have a correct domain to use for this tutorial. Step number one, we're going to update the environment variables. These are the environment variables you're going to need. Step number two is we're going to create the cluster, and it's going to update some IAM roles as well. So we're going to have to go through the source code files and update the IAM roles. Step number three is to access the cluster. Number four is to bootstrap it with FluxCD. 5 is to create all of the customizations, which are the resources in here. 6, we're going to create a test deployment. 7, cleanup. All right, let's go ahead and get started. Take some time to update the environment variables if you clone the repo. Go to this file here. Update the cluster name down below with the name that you used in the environment variable. You should also update the pipeline default values for the role names. The role names, if you look at the Terraform code, if we go here and IAM, you'll see that the role names use the name of the cluster in them. The benefit of that is in case you are creating more than one cluster, then you'll be able to run this Terraform code multiple times. So if we go to the pipeline code, right here, you want to have the cluster name updated in front. If you use EKS minus flux as your cluster name, that'll probably be the easiest way because then you won't have to modify anything. Okay, so that's going to be an install FluxCD and install FluxCD customization files. In EKS, Terraform EKS main.tf, you'll notice that there are managed node groups right here. You can decrease the number of nodes and the instance types if you want to control the cost of your cluster better. So if you run this cluster and keep it running for too long, it can get pretty pricey. So when we run this tutorial, we'll create it and then destroy it right after we test it, just to keep costs down. Step 2 is to create the cluster using Terraform. So there's a pipeline in here, AWS Terraform, run. You can plan it the first time. If you have an IAM role to assume, you can add that here. The pipeline is now running. You'll notice that the pipeline creates an S3 bucket and DynamoDB table for you. That'll be used by Terraform to make sure that it can save the backups and that not more than one Terraform process is running at the same time. So the plan is good. You can scroll through to see all of the resources that will be created. This time, let's run it with the apply option. It'll actually create the resources in AWS. You can see it's running here. This will take a while to run. Give it 15 to 20 minutes. Take note of the different Terraform files that we have in here. The main file is going to create a VPC and the actual cluster itself. with a few other resources in there. The IAM file is going to create two different IAM roles, an admin role and a viewer role, and then it'll apply a few policies to them. It'll also create two different users. One is an admin user and the other is a viewer user. Note that the cluster name is in front of all of them. Now, in this access.tf file, this is where we're going to associate the IAM role we're creating to the EKS cluster itself. So that way, anyone who can assume this role can be an admin to the cluster. Same with the view-only role. So anyone who can assume this view-only role can be a viewer of the cluster. We also have a secrets.tf file. This is going to create a private key and create a parameter store value for that private key. This is going to be useful for your certificate manager later on. It'll be able to create certificates. One other area that you may need to update the cluster name is in this file. So you can see right here, the cluster name has to be in the beginning of that. That's going to match what we have in the Terraform file. So if we go back to that Terraform file, you can see that the cluster name goes before the name cert manager issuer private key. And we can see that right here. This directory, Terraform EKS service accounts, is going to create the different IAM roles that'll allow your pods to connect to AWS. These service accounts are special. If we look at one of them, we'll see that we're creating an IAM policy for them, and we're creating a role. The role will be attached to the policy. But what's really important and what's special here is that we're going to allow this principal to assume the role. So how does it do it? It uses the OpenID connector of the Kubernetes cluster. So essentially, any pod that is linked to this service account will be able to use this IAM role. When your cluster attempts to assume this role, it'll use the OpenID provider, connector provider. And it'll have this unique web URL. So if it is using that to connect, it'll be allowed to assume the role. So these are all of the different service accounts that we're creating. We're creating one for a load balancer, cert manager, external DNS, external secrets, and these will allow different access to the AWS account for a pod. So a pod will be able to be associated to these service accounts and access the role securely. To learn more about access associations and service accounts, refer to the documentation here. So these are the different access associations that you can have. There's actually a few more, and you can list them running this command once you have your cluster set up. But ultimately, what these do is allow an IAM role to have permissions in your cluster. So anyone who can assume an IAM role that is associated to your cluster can run different commands in your cluster based on these different policies. So if you, for example, were to give someone the edit policy, then they would be able to perform edit in your cluster, edit commands. The view policy, they would not be able to edit anything, only view. The admin can do anything. Okay, so these are the different access policies. You can use the CLI to set them up, or Terraform. We use Terraform to set them up so that we don't have to run CLI commands afterwards, right? So typically you would have to run the CLI command to associate a role to a policy, but that's what the Terraform code did for us. Now the service accounts, pretty similar thing. What they're going to do is allow a pod to assume an IAM role. So in this breeding here, you'll see that You can assign an IAM role to a Kubernetes service account and then configure a pod to use that service account. So if you click into here, for example, you'll see that we're creating a policy and then using the AWS CLI, getting the OIDC, OpenID connector provider URL, and using that to create a role. Okay, this is the trust relationship for the role. And then you create the role. So that's exactly what we did in Terraform, right? So that you don't have to manually come over to the docs and follow these steps. You can just do that in the Terraform code. When the pipeline's all done, you can look at the apply output to see everything that was created. "98 objects. Part of step 2 is we have to update the Helm releases to match the IAM roles that were created. You really want to get this step right, because if you don't, then when your pods are running, if you update it after, you're going to have to terminate the pods and recreate them for them to get the new service accounts. So if you do it right the first time, it'll prevent you a lot of troubleshooting. You can log into your AWS console and search for EKS-flux under IAM and roles. Okay, and in there you'll see a number of different roles. So what we'll do is we'll go to our repo here, navigate to Flux, Helm releases, and there's 5 directories. Click into each of them, go to the Helm release, and down below, update that to match exactly what's in here for each one. So for example, this one, we have AWS load balancer. So we'd go here, click into here, load balancer, copy the ARN, go back, and update it. This is very important to get right the first time if you don't want to spend time troubleshooting. So you can go through each of these: Helm release, cert manager, go back, find the cert manager, copy the ARN, and update it here. Do that for each of these Helm releases. Next, we'll want to update the Apex domain in these files. So if we go to this one first, the Apex domain is what I have highlighted right now. You're going to want to update that to whatever is in your Route 53 hosted zone. Next file, issuer. Right here. Update the Apex domain here. In the next file, the wildcard certificate. This is going to be a SSL certificate for any subdomain from this wildcard, from this Apex domain. So you're going to want to update the Apex domain so that you can issue a certificate for any subdomain. Don't forget to update the email and issuer as well. Okay, once that's done, then we can move on to step 3, to access your Kubernetes cluster. So to access it, you're going to have to use an IAM user who can assume the EKS admin role. There was one already created for you by the Terraform code. You can use that user, or you can use the AWS user that ran the Terraform code, because that user is also associated to the role. The easiest way is if you use the Terraform user that ran it, but you might have to create a web login for that user. Just be conscious of that. and give them Cloud Shell access. Okay, so if you don't have that set up, then you could do it for the user that was created by Terraform. You can create a web login for them and give them Cloud Shell access. You don't really need all of that. You could do it through the CLI on your computer locally, but it's pretty convenient to be able to just go here. So right now I'm already logged in as the Terraform user, and I'll just click on the Cloud Shell. So it's really convenient if you just have it set up like that. So once you're logged into Cloud Shell, you should go to your Bash profile, and you can see I already have mine set up. But what you could do in yours is go to this directory in the root of the repo called resources. There's a little bit of shell code right here. If you copy this code, update your cluster name and your AWS account ID, then it'll automatically create a kubeconfig file for you and install FluxCD and EKS-CTL. So you'll be good to go. You'll be able to run all your kubectl commands that you need, FluxCD commands, EKS-CTL, if you put this in your Bash profile. So if I look at my Bash profile right now, this is what I have in there. Okay, and if I quit that, it already ran. So I should be able to just go, in fact, instead of typing kubectl, there's an alias in there for K. K get namespaces. And there we go. I'm already authenticated in my cluster. It's been up for 18 minutes. And I could pretty much do anything. K get pods all. And there we go. These are all of the pods that are currently running, right? It's not much yet, so let's clear the screen here and move on to the next step. Step 4 is to bootstrap FluxCD. So when you bootstrap FluxCD, you are authenticating within your cluster, and then you are running the bootstrap FluxCD command, which will create a namespace in your cluster called Flux System. And then it'll create a deployment key in your GitHub repo. The deployment key will allow the Flux System namespace to connect to your GitHub repo, read it, write to it if it needs to, and then apply whatever changes it needs to your Kubernetes cluster. So for example, if your GitHub repo is telling Kubernetes by us having a source file to create a namespace, then FluxCD will be able to read the GitHub repo, recognize that we want to create a namespace, go into Kubernetes and update Kubernetes to have that namespace. So let's go back to our actions. Bootstrap FluxCD. And you have to have a personal access token set up. If you set it up in the environment variables, you're good to go. You don't need to put it here. So go ahead and run the pipeline. While that's running, let's look at the code. This command is going to create your kubeconfig file, which will allow it to authenticate to the Kubernetes cluster. Install FluxCD. Make sure we have a PAT set, and then run the bootstrap command. There are different options to run this command, so if you're running this within an organization, you may need to look this command up, but for the most part, this command should be good to go. After the bootstrap pipeline is done running, you'll notice in the settings of your repo under deploy keys that you have a deploy key in there. This is what FluxCD is going to use to read and write to your repository. This is the public portion. The private key is stored as a secret in the Kubernetes cluster itself. So if you go back to Cloud Shell and run K, I had to restart my Cloud Shell. Sometimes it'll freeze up on you. You can just hit actions and restart. So K get namespaces. We can see we have a namespace called Flux System, right? We could run another command, K get customizations minus A for all. And we can see that we have a single customization created. So what is that? If we go back to our repository here, go to Flux, you'll notice that there's a folder called EKS-flux, flux system. Go into it. You'll see this is the customization. It's actually right here. This is the customization I was looking for. This customization is different. It's just a resource list telling FluxCD which files to include in this customization. So this customization is telling FluxCD to synchronize from this path in this repository. So this is linking a GitHub repository right here to FluxCD, and we're giving it the name Flux System. So if we go back to our Cloud Shell and run the command flux get sources git, we can see we have one source that we're replicating from, reconciling from. It's this Git repo. Okay. If you want to add more than one Git repo, you can. You can have one cluster monitoring multiple Git repos just by adding more of these objects into it. But the bootstrap command is going to create this one for you and other necessary components such as the private key, right? So if I go to Cloud Shell, if I run k get secrets -a, then we can see we have a flux secret there. That is the private key to the deploy key that you see here. All right, so looking at all of this again, we have our customization. We're saying anything in this folder is going to be copied into the cluster. So we have this customization list. It's not just anything in this folder, it's anything that this customization list specifies. Okay. So we've completed step 4, we've bootstrapped FluxCD. The next thing we're going to do is we're going to create the customizations. So you might want to read the docs on that a little bit here. I'll pull it up. So this is what a customization object is. Essentially, it is going to watch a Git repository at a specific path for changes, artifact changes. So it'll be building any YAML manifest located in that path. All right, so if we go back to our repository here, go to actions, there's an action called add customization. Pay attention because we're going to have to do them in a specific order. So the first one that we will do is external DNS. So let's go ahead and run the pipeline. External -DNS. You want to make sure that the name matches exactly what is in the repository. So I'm just going to go to Flux, Helm releases, external -DNS. External -DNS. Good. Let's go ahead and run it. While that's running, let's look at the code for this. What it's doing is just like before, we're generating a kube config file so we can authenticate to the cluster. As long as the Terraform user can assume the IAM role, they will be able to perform these actions, which the Terraform files associate the running user with the role. So you should be good there. It's going to make sure that you're using one of these two directories. That's not unique to FluxCD. That's just the way that I wanted to have it set up. I wanted to only have customizations in here or here. Then it's going to check if the directory exists. If it does not, it'll create it and add this file to it, which is creating a namespace. So when it creates the customization, if it's a new one, it's just going to create an empty namespace. That's all. And otherwise, if it's already there, it's just going to skip over it. And in our case, all of the directories are already there. So they're just going to be skipped over. But if you create a new one, it'll create a namespace for you. And then we're going to run this create customization command, which is going to generate a YAML file and then push it to the GitHub. So only run this pipeline one at a time. Don't do it for all of them because then it's going to have issues pushing to the GitHub. So let's see if it ran. It did. So add customization to directory. Good. Now we can go to Cloud Shell and we can check if it's there, but in case it's not, you can always run this command, flux reconcile source git, and then the name of the Git repo, which we saw earlier, was flux system from running the, oh, it was this command. Yep, flux system. Okay, so why wouldn't the customization be there? It would only not be there if Flux has not automatically reconciled from the Git source on its own. It's configured to do it every 2 minutes anyways, so it probably doesn't need to run this command, but just to show you that we can run this command to force it to go to the Git repo and reconcile from it right now. So now we should be able to run the Git customizations command. And there we go. We can see that we have external DNS configured. It's ready, so there are no errors. And now the next command is flux get Helm releases all. Let's take a look. The Helm release was successfully installed. Good. So if there was any issues with the YAML, it would have been identified here. And if there was any issues with your Helm chart, it would have been identified here. So let's go ahead and take a look at what the README says now. So those commands are here. And in the README, we have the link to the external DNS. Let's click into that and let's look at what the external DNS looks like. This is the artifact hub, which is where you get the documentation for the different Helm charts. And this is the documentation for it. There's an area here called default values. This is where you can change the different configurations to the Helm release. Okay. If I go back to my repo and go to Flux, Helm release, external DNS, these are the files that are already in here. There's a customization, which is just a list of resources, which ones to run. There's a namespace, creates a namespace. There's the Helm repo. It's just linking to the repository here. So if you put your mouse over that, you'll see the URL of the repo, and we'll see that's what we have right there. And then there's a Helm release file. So there's a link here called Helm release template. If you click into it, then it'll take you to this file, which will show you the template for using a Helm chart with FluxCD. This is unique to FluxCD. So when we have FluxCD installed, we can use a custom resource definition called Helm release, which will release a Helm chart with the values that you have underneath the values of underneath spec. Okay, so spec.values. These are all of the values that you can add here. If we go back to Artifact Hub and take a quick look, that's all of these values. So for example, if I type in service account, here it is, service account. By default, it's set to create true. Annotations. Let's go back to our code. This is our Helm release for external DNS, values, service account, name, annotations. Okay, so we can customize any value we want in the values area, and we get that information from here, looking at the default values. So for example, if I wanted to turn the liveness probe off, I could update that here by enabled to false. So all I'd have to do is go to here and add underneath values, liveness probe, and then under it, enabled false. Okay, I'm not going to do that because I don't want to do that, but that's just the way you can edit the different configurations within your Helm charts. So let's go ahead and run the pipeline to create the other Helm releases. Let's take a look at which one is next. The next one is external DNS. This one has some requirements that we're going to have to follow. So be careful when we install this one. So let's take a look at the files first. Okay, so we'll go to Flux. We'll go to Helm releases, external DNS. Sorry, external secrets, right? And there's two different customization files in here. The first one has this commented out. The second one does not, and it has the extension full. Any file that does not end in YAML will be ignored by FluxCD. So we're ignoring this file the first time. Why are we doing that? Because we want to install this first without this object, and then afterwards we're going to replace it with this one to install that object. What's that all about? These three up here is going to install the Helm release file. The Helm release file is going to install custom resource definitions, CRDs, that will then allow you to create these types of objects. You can't create this object until this is created, is basically what I'm trying to say. This is going to create custom resource definitions that'll allow you to create this object next. So first, we're going to use this file. After it's successfully installed, we're going to use this one. Okay, let's go run the pipeline now. Go to Actions, Add Customization, Run. Make sure the name matches external minus secrets. External minus secrets. Go ahead and run that. It shouldn't take too long. The last run was 15 seconds. When it's done running, go to your cluster. You can run the reconcile command again if you like. You don't have to. It should pick it up pretty quickly on its own. And here we go. K get customizations, reconciling, in progress, unknown. Okay, let's take a look at the Helm releases. Okay, it's still installing. So you have to wait for this to finish installing before we can update the files to using this one. So let's just go ahead and wait for that to happen. While you are waiting for it to reconcile, you can run k describe customization and then the name of the secret and then the namespace, which in this case is Flux System. If you run that command, it'll give you a summary of what is happening with the customization, including events. So we can see that it was progressing and it succeeded 13 seconds ago. Good. So now if we run k get customizations, we can see it's all there. And if we run get helm release, we can see it is true. It is ready. So the next step is if we go back to the README to rename this to install.install and the one with .full to .yaml. I mean, it's just a comment, right? Like you could have probably just achieved it with comments, but you know, just remove that comment. But either way, we'll just do that this way. So we're going to call this .install. And you could do it however you like. You could even create another directory and remove that and add that from your original customization. So there's a lot of ways to do this. It's not really, the point is that you don't have this file there the first time and then you have it there the next time. Okay, that's the point. So now if we reconcile again, and then look at our customization and our Helm release, looks like we're good. So it was able to create the cluster secret store. Okay. And if you want to verify that, you can go back to here and run k get namespace external secrets. There you go. It's been up for 40 seconds. If you tried to create it all at once, this would have given you an error because it needed to install the Helm release before it can create this object. So that's the whole purpose of us having to do that with the files. And again, you could have done that in many ways. You didn't have to rename them like this convention. If you don't like that, you don't have to do it that way. The next thing we're going to install is cert manager, and that's going to follow the same procedure, right? So let's go ahead and take a look at that cert manager. So we have the customization here, which is going to exclude these objects, and then we have the full one here, which will include them. So let's run it. Add customization, run. The name of the directory, make sure you get it exactly right, cert minus manager. Cert minus manager. Now run that. Wait for it to finish. After it's done running, you can go to your Cloud Shell again, or your CLI, however you're running it. You might be running it in your terminal or whatever. So we can run git customizations again. It's not there. Let's reconcile, so we don't have to wait a couple minutes for it. And then git customizations. There we go. It is in progress. Good. Let's look at our Helm releases. It is installing. So give this one a minute to run and install, and then we'll follow the same procedure we just did, where we will swap these two files out to run the one with these objects too. Again, we can't create this issuer object until the Helm release is created, because it's going to install the custom resource definitions required to create that Kubernetes object. There's also a watch option you can use. So you can watch, and anytime there's any update to the command, it'll print that update to the standard output. So you can add the watch option to it if you like. Even the Flux Git Helm release command has that. And again, we can do the describe command. So we can run k describe customization cert manager namespace flux system. And there we go. We can get the description of that customization. But more importantly, we get the events that are happening. So it was progressing, created the Helm release, created the Helm repository, progressing, and all good to go. So now if we run k-git customizations, we can see it's ready to go. We can run flux git Helm release all, and we can see it is ready to go. So now what we do is we want to install the objects issuer insert secret. So we'll just go to these. Again, you could just uncomment these if you want to. I kind of, for this tutorial, I thought it was appropriate to have two different files. So I'll just rename this one here. Let's rename it to customization.yaml.install. So now it won't install, it won't read this anymore because it's not a YAML extension. And then we'll go to the full and we'll remove the word full from it. So it'll deploy this one. Go back to our repo here, reconcile. Okay, and then look at the customizations. That was pretty fast. Let's see if everything got deployed. So we have an issuer, cluster issuer. Okay, let's copy that. And let's go k get cluster issuers. We can do -a for all namespaces or -n and then type the namespace. So here we go. It's created and it's ready to go. Okay. And then what was the other object that we had in there? It was this one, the external secret. So let's go ahead, and you could use external secret or you could use secret when you type kget. So kget secrets. We could do -a for all of them, or we could specify only the ones in this namespace, cert manager. Okay, so it created a few of them on its own. That were created when the Helm release was created, and then we have this private key one created as well. Okay, this is good. Remember, you have to have the external secret made before you can create an external secret object in here, right? So just keep that in mind. We probably didn't need to comment that one out in here, but we definitely needed to comment it out, the cluster issuer. Okay, either way, we're doing good. So let's take a look. We've gone through, oh, this isn't updated. We've gone through these first 3 Helm releases. The next 2 should be okay. I don't think there's anything in there um, that will be required. Let's see, does this one have anything? This is from Cert Manager, so no. So the next 2 we can run installing everything at once. So first we'll install load balancer and then ingress nginx, right? So let's go ahead and do that. Add customization. And the name on this one is kind of long, so make sure you get it right. AWS minus load balancer minus controller. AWS minus load minus balancer minus controller. And my autocorrect did that. AWS minus load minus balancer minus controller. Run that. And when it's done running, it's going to be the same process. We're going to go to Cloud Shell and watch it until it's done, verify it's working, and then move on to the next one. Okay, so that one ran. And then we're going to reconcile the source so we don't have to wait 2 minutes for it. It'll pick it up right away. And then let's see what it's doing. Okay, get customizations. It's in the process of reconciling. We can do k-describe customization, AWS load balancer, controller. It's kind of a mouthful, flux system. And here we go. These are the events that happened. Normal, progressing, normal, progressing, done. Great. Let's take a look. All done. Flux get Helm releases minus all. It's ready to go. Very good, very good. So the next step is to create the last one, ingress nginx. Okay, and again, if you want some clarification on what these are doing, the links to their documentations are all here, and a little summary of them is here, what they're doing for us, right? This one allows you to modify domain records of DNS names that are in your account. This one allows you to access secrets that are stored from external sources. This one creates and manages SSL certificates for you. This one creates and manages load balancers for you. And this one handles incoming internet traffic to your cluster. Okay, so now we can create the ingress nginx. So let's make sure we spell it right. Ingress minus nginx. Okay, run. Ingress minus nginx. So let's run that and follow the same procedure where we wait for it to finish and check it out in Cloud Shell. So the run was done. Let's reconcile so we don't have to wait. Let's look at the customizations. Okay, describe customization, ingress, nginx, namespace, flux system. Okay, so it's still going. We created these objects so far. We can watch so that we'll get an update when it's ready. Okay, and if you hit Control C, you'll get out of that watch command, and you can see right here that, oh, nope, maybe that was the wrong one I was looking at. Let's take a look. Yep, it's still running. Okay, just keep waiting for it. It'll finish up here. We can run the describe again to see how it's going. No updates. This one probably will take the longest out of all of them. So here we go. We have it running right now. It's all there. And then let's look at the Helm releases. Good. It looks like the Helm release has been successfully installed for all of our Helm charts. So we are good to go. Let's see what's next. Next, we're going to create a customization for the app that we want to deploy. So I've already got the folder in there, test minus site. So let's run the add customization again. It's going to be test minus site. And down here, it's going to be in the apps directory. Again, you can structure this however you like. This is how I chose to structure it. I want my Helm releases in this directory, and I want my apps in this directory. So if I run that now, while that's running, maybe I should really quickly show you where those files, where those customizations are being created. Under Flux and the name of your cluster, there's a directory here called Helm Releases Customizations. Click into there and you'll see an individual customization object for each of the Helm releases that we're deploying. You don't have to do this. You could just use one customization for all of your Helm releases. I really like having them separated because then you get really good observability of your errors per chart, right? So it's really nice to have them separated because then when you run your kubectl get customizations command, it'll show you the errors in each individual one. Okay, so it's kind of nice for troubleshooting and observability. So now we have just created a new folder here, and this is going to be the customization for this path, Flux Apps Test Site. So if I look in Flux Apps Test Site, that is here, we have a customization list again, resource list, that is telling us to deploy all of these files. So what do we have? We have a namespace called test site. We have a deployment in here with 2 replicas. It's a really basic deployment. It's just an Nginx website. And then we have a service for that. The service makes it accessible over the network, your pods that match that selector. And then we have an ingress. The most important line here really is line 9. We're telling it to use the Nginx controller for the ingress class. You could use the AWS load balancer one, but the problem with that is it'll create a new load balancer for every ingress object that you create, and that's going to increase cost. If you use the Nginx controller, it's going to use one load balancer for every ingress object. Now, this is the domain here, so in a couple minutes, we should be able to access our deployment through that domain. It links to the deployment through the service, though. This is the backend service, the name of the service, right? So this is the name of the service. The service redirects traffic to any pod matching that pattern. If we go here, we can see there it is. That's where the pod, it's actually right here where the pod matches. Okay, so now let's go to our instructions again. We have some commands that we can run, right? So let's run them. We have k get namespace. Let's just grep for test. Let's see if it's ready. It is. Okay, and let's run k get pods test site minus n. Sorry, minus n test site. Okay, so we have these pods. They were created 2 minutes ago. I think the namespace was created a while ago because I accidentally left the customization in there earlier. I deleted it though. So that's why the pods are now being created. So these are the pods in here. If we run k get deployments minus n test site, we have one deployment with 2 available, right? Replicas, 2 pods, 2 containers running in them. So now if we run k execute to execute a command in it, you have to give it the minus IT option if you want to be able to see the output of the command. And then the name of the deployment or pod, deploy minus nginx minus deployment. So that's the name of the deployment, and this is telling it to execute it on the deployment. Namespace test site curl 0.0.0. So we should be getting Look at that. We executed the command curl any host on that deployment. And this is what it gave us the output. Okay. So we could probably run a lot of commands, right? We can run k get svc for services. So that's our service that we have in here. We could also run k get ingress test site. So this is our ingress. We should be able to take this domain and access it in our browser. If it doesn't work right away, then give it a couple minutes. If it's still not working, then you probably made a mistake in your service accounts, and I'll show you how to double check that just in case. So here you can see if you go to that domain that you have from the output of running k get ingress -n, then we can see the same web page here that we saw right here when we run the curl of that command in the container. So the next thing to do is to look at the logs. K logs, and you could use the pod name again, but if you don't want to have to copy and paste, just use a deployment. Nginx -deployment namespace test site. So we can see the access logs here. It's kind of nice. So every time I run this curl command, if I run it a few times, and then k logs, we can see new records coming in for that. So that's good to know. Let's go ahead and clear the screen. K describe deployment nginx deployment namespace test site. This is going to run the describe command on it so that you can see the details of it. It's really important to know this command because the events area will give you a lot of details. It's also good to run, instead of deployment, to do it on the individual pods when you're troubleshooting. That'll help you out really good. But if you're not getting the site to come up, if you can't see it in your browser, most likely you made an error in the service account somewhere. So how are we going to troubleshoot that? The way to do that is to go k. It could be a little tedious, right? You might want to run k get service accounts -a. Well, you know what? That's going to be too many. Just pick one of the namespaces that we deployed from the Helm charts, so such as cert manager. You have to put -n in front of it. There. So k get service accounts -n cert manager. You're going to see these different service accounts that are created. You're going to want to describe this one right here because this is the one that we created, right? And if you want to verify that, just go to your Helm releases, cert manager, Helm release, service account, name, cert manager. Okay. You're going to want to then verify that the role here matches. So you can go k describe service account -n cert manager. And in there, you should be able to see the IAM role. Okay. Then make sure that it matches what you have in AWS. So navigate to IAM in a different tab and look for that role. So let's see, cert manager, right? Here it is. You're going to want to make sure that this matches exactly what you have in here and here. If it doesn't, then you're going to have to update it and delete the pods and recreate them. So to delete the pods and recreate them, the way to do that is going to be to run flux get Helm releases, and then to suspend a Helm release. So if we're talking cert manager, maybe we got the service accounts wrong, right? Then you're gonna, after you update it, flux, suspend, Helm release, cert, manager, -n, cert, manager. So you run that command and it'll not synchronize from the, it'll not reconcile from the Git source anymore for that Helm release. And then you would have to delete the pods that are running in this namespace. You can go k get pods -n cert manager. So you would just delete whatever pods are in here so that when they get recreated again, they'll have the new service account. You could just nuke the whole namespace, k delete ns cert manager. You could do that. Now, after you delete everything, what you would do is you would resume the Helm release, right? So flux, you know what? I'll just do this. Flux, suspend, Helm release, cert, manager, namespace, cert, manager. I'm commenting this out because I don't need to run this. And then you could do your deletion of the pods, or you could just delete the entire namespace. So k delete ns cert manager. This is only troubleshooting, right? Like if you can't see the site, you probably got the service accounts wrong. So after updating the service accounts, we're just going to run this procedure. Flux, wait for them to delete, right? You might have to check the pods again. Run this command again, make sure it deletes. When it's all deleted, flux, resume, Helm release, cert, manager, -n, cert, manager. That should do it for you. Once the Helm release is resumed, it should identify that, oh, we don't have any pods in there. Let's create them. And if you really need to, you can also delete the Helm release and then run reconcile and it'll recreate it for you. Either way, it'll be a little bit of a journey for you to get those pods reset and the service accounts going, but it won't be too bad. And once you get that going, eventually you'll be able to see your site if you can't see it. Okay, so that should be pretty much everything on deploying. And then we ran through all of these commands here, right? We looked at the logs, we executed a command in our pod, we ran the description. Okay, so the next thing to do is to clean up. You don't want to keep this running for too long if you can, because it is kind of expensive to keep it running. I don't have that information in the repository on pricing details. You'd have to look that up yourself. But EKS has its own cost, and so does running each of those nodes. Okay, so you're going to want to be conscious of that, and you can look that up on the Amazon documentation. But the thing we're going to do first is just delete the ingress object. So let's just go to here, customizations, and just comment that out to delete it. Really easy. Go back here. Flux reconcile source git flux system. Okay, and then k get customizations -a. Says it's done already. Let's check. K get ingress -n test site. None. Perfect. We have to get rid of this to run the destroy pipeline, because if this is there, it won't destroy the load balancer. You still might have to get in there and do some cleanup at the end, but for the most part, we should be good to run the destroy pipeline now. So we can go ahead and run the destroy pipeline. So let's go here, AWS Terraform, run it, give it the destroy option, and the folder containing the workspace you want to run Terraform from. So run that. And that's going to take, it's probably going to take longer to run than the creation of everything. So just sit tight, let that run for a while. While that is running, down below, there is some other things you could do for the cleanup, such as delete the FluxDir. Maybe you don't want to delete the entire FluxDir because you'll lose some of those files. But what you'll want to do is to go into Flux, EKS minus Flux. That's the dir you want to, the name of your cluster, Flux/cluster name. So if you delete everything in here, that's a good step because then when you deploy this again, it won't automatically try to deploy all of these customizations. You don't want them to deploy on their own because you want to install them one at a time. Remember, there's dependencies, right? So, for example, if we look here, the ingress nginx requires the load balancer to be created first, right? The cert manager requires the external secrets to be created first. So that's why we don't want them to all be created at the same time. So just get rid of this whole directory. And this one got created by FluxCD. So getting rid of this whole directory is fine for the cleanup process. And you can leave the Helm releases in here. That's convenient. So that way, if you want to deploy this again, you don't have to recreate these files. You just have to run the pipeline to create the customizations for them again. So let's go back over here. Let's take a look. Is there anything else we should do for the cleanup? We may want to rename the customization files. Yeah, that's a good idea because just if you remember, these customizations had dependencies, right? So this was the install one. This was the full one. So let's rename this to full. And then rename this one by removing install. And I believe external secrets also had that. Okay. The destroy pipeline may fail. That's okay if it does fail. You'll see that it destroyed pretty much everything. The only things it didn't manage to destroy is your VPC and subnets. So what you could do is simply just log into the console, type in load balancer, search, and then delete any resources in there. So after you've deleted that, then go back to VPC, click on your VPCs. You should be able to delete the VPC that it created. So once you've done that, you have completed the cleanup. So there's nothing else left in your AWS account that was created from the Terraform code. Just make sure to perform that cleanup. So thanks for watching on that one. I hope that was very helpful for you. And if you do get that running, I would love to hear about it in the comments. Thanks.